All right, let's jump straight into this explainer on the Cambridge IGCSE Physics Math Skills Masterclass. Today, we're taking aim at one massive systemic study myth. It's literally the one thing standing directly between the grade you have right now and the target grade you actually want. So here's the myth, this idea that ordinary revision is enough to secure top marks. Let me tell you, that is probably the most dangerous mindset you can carry into a 0625 exam. Why? Well, because ordinary revision just completely fails when you're bleeding easy marks to simple prefix errors or, basic rounding mistakes. You could understand the complex physics perfectly, like you've totally nailed thermodynamics and electromagnetism. But if your math skills foundation is shaky, the mark scheme is going to penalize you heavily before your actual physics knowledge even gets tested. Look at this list. These are the painfully common mistakes that act as silent killers for high grades. I mean, if you drop units in your final answer, or if you round a number way too early in a multi-step calculation, your grade boundary crashes before the examiner even looks at your core conceptual understanding. Things like vague scientific explanations, scaling your graph axes so awkwardly that no one can read them, or offering super weak practical improvements. These are all math and data processing skills. They require a precise, targeted strategy, not just passively flipping through a textbook.
Which brings us to our very first quick win, Chapter 1 of the Math Skills Grid. Think of this as your absolute baseline defense. It's all about choosing the correct unit for a variable and using the proper symbols. I know, it sounds incredibly basic, right? But examiners have literally built an entire grid just to highlight this as a foundational skill. By locking down your units and variables the very second you read a question, you're basically building an impenetrable wall against those silly calculation errors. Now, moving down that exact same grid, we hit a massive stumbling block for so many students: significant figures. Getting this wrong is an absolute classic trap. The grid specifically flags determining the correct number of significant figures as a critical skill you have to master to satisfy the mark scheme. Look, if your raw data is given to 2 significant figures, your final answer absolutely should not be some sprawling 10 decimal place number you just copied straight from your calculator screen. No way! You've got to match the precision of the raw data. And to truly conquer the numbers, you also need to master the extremes. Following these 3 steps to handle standard form and tricky unit prefixes will instantly secure calculation method marks that most students just carelessly throw away. First up, you must be super comfortable converting numbers to and from standard form. Second, you've got to seamlessly interpret values with unit prefixes, milli, micro, kilo, mega, all of those. And third, you have to actually carry out arithmetic operations while keeping those numbers in standard form. If you nail this, you've just insulated your grade against the absolute most common unforced errors. Okay, let's see how this all builds into chapters 3 and 4 of our grid, because this is where the stakes escalate dramatically. We're talking about drawing and interpreting graphs. Here, you aren't just crunching a single number. You're actively analyzing relationships. You have to pick the right variables for your axes, choose the absolute best scales for accuracy, and then properly plot your points to draw that perfect best fit line. And interpreting straight line gradients to find the intercept? Honestly, that's exactly where the top tier marks are hiding out.
But wait, hold on a second. There's an exact examiner clue coming up that completely transforms how you handle data analysis. To unlock those high-value evaluation marks, we actually need a specific structural framework first. That's what makes all this advanced strategy finally click into place. So here it is. That unbreakable framework is a simple 4-step process you can use for any data or written response. Step 1, declare the core physics concept. Step 2, inject the data from the question or your calculation as evidence. Step 3, add your scientific reasoning to really connect that data back to the concept. And finally, Step 4, finish up with exam-safe phrasing that aligns directly with the command words. Stick to this framework, and I promise you, your answers become completely bulletproof.
All right, let's test this right now. I'm challenging you to a quick pause and predict. Based on the framework we just walked through, where do you think most students completely derail their graph interpretation answers? Just think about it for a second. When they're asked to describe a relationship on a straight line graph, which step of our 4-part framework do they almost always forget?
Well, if you guessed evidence or data, you hit the nail right on the head. Just look at the flawed student answer on the left. It simply says, the graph goes up, completely missing the units, rounding early, and totally failing to use substituted values. But then check out the top band improved answer on the right.
It flawlessly combined substituted values, actual coordinates extracted straight from the line, with our exact framework, clearly stating that as variable x increases by this specific amount, variable y increases proportionally. That right there is how you secure those top marks.
Now, we can escalate this to a much harder example, straight from the grid, interpreting curves on graphs. So we're not just dealing with a simple straight line anymore. Extracting data from a curve to figure out when a relationship is inversely proportional, that requires you to test multiple data points. You actually have to multiply the x and y coordinates at different points on the curve and prove that they equal a constant. It requires serious precision, and you absolutely have to show you're working clearly. Okay, get your virtual red pens ready. It's time for a checkpoint. Imagine you've extracted data from a curve, but one point is just wildly off the line, a total anomaly. I want you to sketch out your own reasoning for this anomalous reading in your head right now. How would you explain it? But be careful. Make sure you don't fall for the weak practical improvement trap. Examiners give literally 0 marks if you just say, human error, because let's face it, that proves absolutely nothing about the physics context. You have to be super specific about the apparatus, the reliability, or the experimental variables that might have shifted. To make sure you never make those vague mistakes again, here is your examiner-style correction checklist. Whenever you finish a calculation or a graph, your final step must always be verifying these exact details. Check your substituted values and make sure the correct units are actually there. Verify your significant figures perfectly match the raw data. Confirm your best fit line is balanced and that your graph scales occupy at least half the page. And finally, assess the overall uncertainty and just ask yourself, is this number actually reasonable in the real world? Doing this guarantees your math perfectly aligns with the physics reality. But here's the thing, we've mastered the numbers, the units, and the prefixes today. You've got the checklist now. But all of this actually creates a massive unresolved problem. What happens when your perfectly calculated data fails the overall evaluation requirements of the exam? Is perfect math really enough to actually get that top grade? Or is there some missing piece to how examiners want you to evaluate an entire experiment?
The truth is, perfect math is just the foundation. To truly replace that study myth with a complete, unbreakable system, and to actually bridge the gap to your target grade, you absolutely must watch our physics top band evaluation framework explainer next. That is where we tackle those really tricky highest level command words.
So whatever you do, don't leave your revision half finished. Click the explainer on the screen right now to unlock that complete evaluation framework. And hey, make sure you subscribe to our channel, Ace the Exams, to excel in your Cambridge examinations. Thank you so much for joining me, and I'll see you in the next explainer.